So a vector describing the position and direction of a particle from the origin is called as position vector. When an object thrown into space with an initial velocity at an angle to the horizontal is called as projectile. The vector joining the initial and final points, we will call it as displacement vector. So consider a body thrown up at an angle to the horizontal with a velocity. Hello everyone, welcome to session 3 of chapter 4, Motion in a Plane. This is Swati, Department of Physics, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. So in this chapter, we are discussing about the object which are moving in 2 dimensions. So the chapter name is Motion in a Plane. In the previous session, we had a discussion about vector operations, in which we have learnt what are vectors, why do we use vectors, what are the uses, and what are the laws of operation, like the sum, addition, subtraction, multiplication, and what are the laws which are followed to add the vectors. So the laws involves triangular law and parallelogram law of vector addition, which are very important examination point of view also. And also we had learnt about the various operations such as subtraction and multiplication. So in today's session, we are going to discuss about some more important terms involving in this vectors and also few more interesting concepts. So the next important term is position vector. So in understanding the total operations with respect to vectors, we need to understand certain important terminologies. So let us now see what is position vector. So a vector describing the position and direction of a particle from the origin is called as position vector. So see here, if this is a origin, so this is a vector which represents the position and the direction of motion, because we know vector has got both the magnitude and direction. Any vector that represents the position and direction of a particle from the origin, will call it as position vector. So in vector form, position vector is denoted by R, and which is given by the sum of all the coordinate axes, that is x into I cap plus y into j cap plus z into k cap. So usually position vector describes the position and the direction of a particle from the origin. So next we have magnitude of position vector. So we had a discussion about the magnitude of resultant vector, which is given by r is equal to root of p square plus q square plus 2pq cos theta. So here also we are discussing about the magnitude of position vector, and it is given by r is equal to root of x square plus y square plus z square. And next we will have displacement vector. What is the meaning of displacement vector? The name itself is defining what it is. So displacement vector is nothing but a vector joining the initial and final position. It is called as displacement vector. We know how to find the displacement. By taking the difference between the final position and the initial position, we will get to know what is the change in position, which is nothing but displacement. So similarly here also, the vector joining the initial and final points, we will call it as displacement vector. So how to represent this displacement vector? Let us take an example. So let us take a vector r1, which is equal to x1 I cap plus y1 j cap, and vector r2 is equal to x2 I cap plus y2 j cap. Now let us find the difference between this final position and initial position. So in this example, vector r2 is the final position and vector r1 is the initial position, let us say. Now to find the displacement vector, we need to take the difference between these two vector forms. So we have r2 is equal to x2 I cap plus y2 j cap, that is the final position, minus the initial position is x1 I cap plus y1 j cap. Now let us write all the I terms to one side and let us bring all the j terms to other side. So what do we get? Bringing all I terms to one side, x2 I cap minus x1 I cap plus y2 j cap, minus into plus is minus y1 j cap. So now same thing we have written here, x2 I cap minus x1 I cap. In this I cap is common, so taking it outside we get x2 minus x1 into I cap plus here we have y2 j cap minus y1 j cap. So taking j cap outside, y2 minus y1. So here x2 minus x1 is nothing but the difference in the displacement. So we can write it as delta x into I cap. Similarly here we have y2 minus y1 and it is given by delta y. So delta x into I cap plus delta y into j cap is the displacement vector. Now we are discussing about the object which is in two-dimensional motion. Correct? So our next topic is relative velocity in two dimension. In the previous chapter called motion in a straight line, we have studied about the relative velocity of an object in one dimension, which means the relative velocity means velocity of one object with respect to the another object. So here we are going to discuss about the relative velocity in two dimension. So let us take two bodies to understand this, that is body A and body B. So let these two bodies A and B are moving with the velocities VA and VB. Since the velocity is a vector quantity, we need to represent this with a vector form. So they are moving with the velocities VA and VB with respect to the ground, which are making an angle theta with each other. Say for example, two bodies are moving with respect to ground, they are making an angle theta with each other. Then the relative velocity is given by VBA is equal to VB minus VA. So VBA is also nothing but a vector, the relative velocity vector. So it is denoted by a vector sign. And here these two bodies which are moving with certain velocities VB and VA, since they are vectors, we have to represent this in a vector form. So whose magnitude is given by VBA is equal to root of VB square plus VA square plus 2VA VB cos theta. This is because the resultant vector can be expressed in the form A square plus B square plus 2AB cos theta. So here we have two velocities, one is VB and the other one is VA. Let us consider VB as A and VA as B, and we get in this form, if we write the resultant magnitude, it is given by root of VB square plus VA square plus 2 VA VB cos theta. So what if the bodies are moving with right angles with each other? If they are moving at right angles with each other, which means like this, VA and VB, if they are moving at right angles with each other, then the value of theta is equal to 90. So what is the value of cos 90? It is 0. So entire this term becomes 0 and we remain with VBA is equal to root of VB square plus VA square. Now we are moving on to one important concept, that is projectile motion. What is a projectile motion? Before understanding the definition or the meaning, please look at this diagram carefully. So here the boy is kicking the ball and which is displacing from one point to another point. So it is making some angle with respect to the ground. So this diagram is enough to understand what is projectile. So now let us understand what is projectile motion. It is nothing but when an object thrown into space with an initial velocity at an angle to the horizontal is called as projectile. Now if the object is thrown into space with initial velocity at an angle with horizontal or the ground, we will call it as projectile. What is the example? The example for projectile is shot put. If we throw the shot put which makes an angle with respect to ground, and if it is thrown into space, that position is making an angle with respect to the ground, we will call it as projectile. And also the javelin throw, shot put, all these are the examples for projectile. So the path traced by the projectile is called its trajectory. The path traced by the projectile is called as trajectory, and usually this trajectory is a parabola. So the path traced by a projectile is called as trajectory, and the trajectory of a projectile is always a parabola. Now the velocity with which the object is projected is called as velocity of projection. So when the object is projected into space, it moves with certain velocity and we will call it as velocity of projection. It is denoted by the letter U. So these are the terminologies or the terms which are related with the projectile motion. The angle between the direction of object and the horizontal drawn at the point of projection is called as the angle of projection. It is denoted by theta. So what is this angle of projection? The angle between the direction of the object which is projected and it is drawn at a point of horizontal. So it makes an angle theta, and that angle is called as angle of projection. Now let us study about this projectile motion in detail. Let us understand the projectile motion with an example. So consider a body thrown up at an angle to the horizontal with a velocity. Here the object is thrown into space which is projected and making an angle with the horizontal. It is moving with certain velocity, and the velocity of projection can be resolved into two components. Now this object is projected and it is moving with certain velocity. The velocity is resolved into two components. One is along x-axis, the other one is along y-axis. So the resolved components are OX and OY respectively. I told you the object is moving with the certain velocity. The velocity is getting resolved into two components. Along x-axis it is OX and along y-axis it is OY. The horizontal component remains constant in the projectile motion. So in the projectile motion, this horizontal component always remains constant, but the vertical component is affected by gravity. So as the object is getting projected at the highest point, velocity component is 0. So at the highest point, vertical component of velocity is 0. So in the projectile motion, time of ascent is equal to time of descent, which means the time taken by the object to move the highest point, which will be equal to, which means the time taken by the object to reach the highest point will be equal to the time taken by the object to move from this point and reaching the ground. So we can say that in the projectile motion, time of ascent is equal to time of descent. So these are the conditions of projectile motion. It says that in the projectile motion, the horizontal component always remains constant. So at the highest point, the velocity component is 0, and in the projectile motion, the time of ascent is equal to time of descent. So all these things we have to keep in mind in understanding the projectile motion clearly. Maximum height is denoted by letter capital H. What is the meaning of maximum height in a projectile motion? So the maximum height reached by the projectile is nothing but the maximum height. So here object is projected into space and this is the maximum height that object can move, and it is termed as maximum height. It is given by a formula h is equal to u square sine square theta divided by 2g, where u is the initial velocity, g is the acceleration due to gravity, and h is the maximum height. Theta is the angle of projection. So we have to remove this formula. To find the maximum height reached by an object, we need initial velocity, angle of projection, and acceleration due to gravity. So next we have time taken by a projectile to reach the maximum height. So how to find out what is the time taken by an object to reach the maximum height? So to find the time of ascent or descent, since these two are equal, to find ascent or descent, we need a formula t is equal to u sine theta divided by g, where u is the initial velocity, theta is the angle of projection, and g is nothing but acceleration due to gravity. So to find time of ascent or descent, we require initial velocity, angle of projection, and acceleration due to gravity. Knowing all these terms, we can find what is the time required by an object to reach its maximum height. So next we have time of flight, which is given by capital T. So what is this time of flight? How it is different from maximum height or time taken for a projectile to reach its maximum? So it is nothing but time of flight is defined as the time taken by the projectile to reach the ground after it was projected. When the object projected, it reaches maximum height. So what is the time taken by a projectile to come back again to the ground? It is called as time of flight. So it is calculated by the formula t is equal to 2u sine theta divided by g. So here also u is the initial velocity, theta is the angle of projection, and g is nothing but acceleration due to gravity. So knowing initial velocity, angle of projection, and acceleration due to gravity, time of flight can be calculated. So here we have to know about the difference between maximum time taken by the projectile to reach its maximum height and the time taken by the projectile to come back again to the ground. What is the difference? So we will call the time taken by an object to come back again to the ground when it gets projected, we call it as time of flight, and it is denoted by capital T. We can calculate this by using 2u sin theta divided by g. Whereas in the projectile motion, the time taken by the projectile to reach its maximum height is given by small t, which is nothing but u sin theta divided by g. Here there is a difference between these two concepts. So we have to write the proper definition for the respective questions. So next term what we have to understand in projectile motion is range. It is denoted by the letter R. What is range? It is nothing but the maximum distance travelled by the projectile along the horizontal distance. So we will call it as range. To calculate range, we need a formula that is u square sin 2 theta divided by 2g. U is nothing but the initial velocity, theta is angle of projection, and g is acceleration due to gravity. So having all these terms in the projectile motion, we can find what is the maximum distance covered by an object along the horizontal, and that is nothing but range. So the range is maximum when theta is equal to 45 degree. When the angle of projection is 45 degree, the range will be maximum. So this is very important point in competitive exams. When theta is 45 degree, the range is maximum. Next we are moving to an important derivation, that is the trajectory of a projectile is a parabola. So we have already discussed about what is trajectory. It is nothing but the path taken by an object when it is in projectile motion. So we will call it as trajectory. Why does it takes a parabolic path? So we are deriving now the trajectory of a projectile is a parabola. So consider a body thrown up at an angle to the horizontal with a velocity. Here we are considering a particle which is thrown up, which is getting projected with the horizontal, and it is making an angle theta with the horizontal, and it is having an initial velocity. Now the velocity of projection is resolved into two components, as I already told, that is along x-axis, along y-axis. Now along x-axis it is resolved into OX, and along y-axis it is resolved into OY. In projectile motion, the horizontal component remains constant, but the vertical component varies. At maximum height, the vertical component is 0. So here, the vertical component is affected by gravity from point to point. At maximum height, it is 0. And P of x comma y be the position of projectile after t seconds. Let us consider this is the position of object P at x comma y. This is the position of object after t seconds. So let us consider it reach a point P after t seconds. So at this time, the horizontal distance travelled in time t is, the horizontal distance travelled by an object in time t is x is equal to u cos theta into t. Now we are talking about the horizontal distance travelled by an object. Since horizontal component is along x-axis, it is x is equal to u cos theta into t. Why into t here? Because we are calculating horizontal distance in time t seconds, and hence it is x is equal to u cos theta into t. So from this we can write t is equal to x divided by u cos theta, and that is our equation 1. So here we know the vertical components affected by gravity. So let us now write the vertical distance travelled in time t seconds, that is given by u sin theta into t. Here velocity component is resolved into two components. Along x-axis, we will get cos theta component. Along y-axis, we will get sin theta component. So here, u sin theta into t minus half gt square, because it gets affected with respect to gravity. So u sin theta into t minus half gt square, that is our equation 2. Now, let us substitute this t component or the value of t in the second equation. So, what do we get? We get u sin theta into t is nothing but x divided by u cos theta. We are substituting the same. So, y equals u sin theta into x divided by u cos theta minus, here you can see we have half gt square. So, in the place of t, we have to substitute x divided by u cos theta. So, we get x square divided by u square cos square theta. Since we have t is equal to x divided by u cos theta, we need the value of t square. So this entire term becomes square and we will get x square divided by u square cos square theta. So we get minus half g into x square divided by u square cos square theta. Now here we have sin theta and cos theta in the denominator. So we get sin by cos is nothing but tan theta. Sin theta divided by cos theta is nothing but tan theta. So here you can observe we have u sin theta into x divided by u cos theta. So here u and u gets cancelled. Sin theta divided by cos theta is nothing but tan theta into x we have, and we have retained as it is, minus we have half g x square divided by u square cos square theta. So here we can write g into x square is gx square divided by 2 into u square cos square theta. So we get 2u square cos square theta. I hope it is clear to everybody. Y is equal to tan theta into x minus gx square divided by 2u square minus cos square theta. So now this is of the form y is equal to ax minus bx square, where b is nothing but g divided by 2u square cos square theta. So if this entire term becomes b, we will get the equation in the form of y is equal to ax minus bx square, which is nothing but the equation of parabola. So here, to relate this with this equation, we have to write the terms. What is a meant for, what is b meant for. So here a is nothing but tan theta and b is nothing but gx square divided by 2u square cos square theta. So these are constant for a given projectile. So equation 3 represents parabola, that is ax minus bx square is the equation of parabola. Therefore we can say that the trajectory of a projectile is always parabolic. Since the projectile's trajectory equation, we are getting it as tan theta into x minus gx square divided by 2u square cos square theta, which takes the form y is equal to ax minus bx square, which is nothing but the equation of parabola. We can conclude it as the trajectory of a projectile is parabola. So in this session, we have learnt about the various terms which involved in projectile motion, what exactly the projectile motion is, what is the meaning of trajectory, how can we say that the trajectory of a projectile is a parabola. So all these things we have learnt in today's session. In the next session, I'll come up with some more interesting concepts. Until then, all of you please take care. Thank you.